This is 6.1, part 2. We want to find the GCF of 18W and 27. Okay, we have a variable in here, so let's look back up how to deal with those. If your terms involve variables, you should write down only the variables that appear in every single term. Well, the only variable I have here is a W, and there's no W here, so W is not going to be part of my GCF. Now I just need to look at 18 and 27. I know my GCF cannot be bigger than 18. Does 18 divide evenly into 27? And the answer is no. If you are struggling with this a little bit, you can always do 27 divided by 18, and if you get a decimal, do 27 divided by 18, and if you get a decimal, it did not divide in evenly. Okay, so let's think of other things that divide evenly into 18. Things that divide into 18, well, 1 does, 2 does, 3 does, 4 doesn't go in, 5 doesn't go in, 6 does, 7 is a no, 8 is a no, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then you get to 18. These are the only numbers that multiply to 18. And if you look, they pair up. 3 times 6 is 18, 2 times 9 is 18, and 1 times 18 is 18. We already said 18 doesn't work. So let's go down. We want the largest thing that goes in, so I don't want to start on this side. Does 9 divide evenly into 18? Yes, we decided that. Does 9 divide evenly into 27? Yes. So your GCF is going to be 9. Okay. So next problem, all right? This one is all variables, and we have negatives involved, okay? Remember, we always have a GCF, even if it's only a 1. We said when we have variables, you should write down only the variables that appear in every term, and then we'll talk about how to deal with the exponents. So I'm building up this GCF right now. There's an x in both of them, so I know my GCF is going to have an x in them to some power. There's a y in both of them, so it's going to have a y in it to some power. Okay, now let's remember that this x has an exponent of 1. It's always implied. So let's look up here. What are we supposed to do with the variables? Exponents. Then you pick the smallest exponent that variable ever has. So what we're going to do is we're going to look at every term we have. There's an x in every one. What is the smallest exponent that's on an x? Well, here's a 4, here's a 1. It's going to be a 1. You don't need to write that in. 1 is smaller than 4. Now do the same thing for the y. Here I have a 3, here I have a 2. So it's that. 2 is smaller than 3. So written better, I have x, y squared. That's a GCF. Now you might be wondering about the negative. You always have the option of putting a negative in there. So you could have a negative GCF and you would just put a negative in front of it. It's like you're saying both of these are divisible by -1. Okay, this is also an important idea in a little bit. Okay. Now what we've been doing here is we've just been figuring out what the GCF is. We are about to start factoring out a GCF. If you look at your factor trees, at the beginning, the first step you have every single time is to factor out the GCF if you have one. Okay, and this is always, always, always your first step. Technically, it could be done later, but your life is going to be much, much, much easier if you do it first, and it has to be done anyway, okay? If you look at this one, the first step is GCF, okay? So, let's look at this first one. These are partially factoring. They've given us part of it, but they want us to complete it, okay? What we want to do, this one is saying, is we want 12p to the 5th And we want it to be equal to 6p cubed times something, and we need to supply that something. So we're asking ourselves, what times 6 will give me the 12? That would be a 2. What times p cubed is going to give me p to the 5th? Here I have 3 of them. I need 5, so I need 2 more. If you think about it, I just phrased that in exactly the same way as when we were doing the long division with polynomials in the last section. All of this is incredibly related. Okay, let's do one more of these. 15x squared minus 30x. This one's a little bit different because it's a binomial, whereas this one was a monomial. If you look at these and imagine having a comma between them and thinking about what we just did, and 15 and 30, the greatest common factor of 15 and 30, it can't be larger than 15, and 15 does divide into 30. So this is the GCF of 15 and 30. Here I have x squared and x. There's an x in each of them. This has a power of 2. This has a power of 1. This is a smaller exponent. This is the GCF. So they found the GCF for us this time. Now the thing is, when you have a binomial or a trinomial or anything with a plus or minus in it, this is going to be a distribution. I want to think about, what do I have to multiply this by to get 15x squared, and what do I have to multiply this by to get negative 30x? Okay, so 15x needs to become 15x squared. The only difference is here I have 2 x's, so I'm going to put an x here. 15 times what gives you negative 30? And negative 2. 15x, that's already got the x on it. So if I multiply here, I'm going to get, this will give me the negative 30, and this will give me the x. So what goes in this parentheses is x minus 2.